an article titled "The Data Scientist's Sexiest Job of the 21st Century." So some of you have probably read this article, or others have at least heard of it, but if you haven't, basically it said that because of modern data tools and cheaper data storage and just a larger amounts of data, there's giving rise to this new field called data science. And some very forward-thinking companies at the time were leveraging data science, to gain pretty big competitive advantages. And they were creating a ton of value for their company. So of course, within a few years of this happening and people started hearing about data scientists, it seemed like every organization on the globe was investing in their data teams. And I was definitely kind of a junior data scientist at the time. And this is probably my attitude at the time, was like, all right, we got it. We got all this data. Let's go get it. We're going to create all this value for our companies. And we're going to do this awesome stuff. And I was actually the first hire at my last company, first data hire, and got to grow that team over the years. And so I learned quite a bit along the way that it's not so easy. So, whoops here. Hang on, I think I'm missing a slide. There we go. All right, so, I mentioned that I thought I kind of had it all, right? So I started off and I was kind of checking off my list, like, all right, I got a place to store all my data in a cloud data warehouse. I had some data engineers who were going to build these automated pipelines to bring all the source data, extract it, transform it, and load it into that data warehouse. And we had data scientists, like I said. I was one of the data scientists, and we hired a couple more. We had a modern cloud BI tool, and we had tons of data. And so, like I said, I was very excited. I thought, oh my gosh, this is great. I have all the pieces in place to be successful. But in small doses, this worked. Okay, we were able to create reporting of things that people previously had zero insight into, which was exciting. And we were doing some analysis and uncovering some trends that people hadn't seen, and people were starting to use data in small amounts. But that early success didn't exactly last. We started to see a lot of problems. It seemed that kind of those small doses weren't very repeatable, and we're having a lot of trouble scaling those processes. So I'm going to go through some of these problems here. And I'm guessing a lot of you can probably relate to these problems. And this factors into that 80-20 rule, okay? Because this often is what data scientists and data analysts and data engineers spend a lot of time dealing with. So one of the first things that I saw all the time, and I've talked to many other people, is having missing or incorrect data, okay? So one day the data is there, the next day something doesn't look right. And I think we've all probably had that heard that dreaded line of, I think something's wrong with my dashboard, right? Like these numbers don't look right. And you never want to hear that. And these problems are often caused by changes in the source data, or maybe your pipelines breaking. I know at my last company, we had pipelines that were constantly breaking or failing, and source data loads just didn't come in right. Or maybe there was a bug in your transformation script that had unintended consequences and suddenly dropped, a few thousand rows or something like that. And in this dummy chart here, we see like this huge plunge, and so it's kind of obvious, like that doesn't look right, but it's not always obvious. And so that's kind of a pretty bad scenario when you have people using data that's incorrect or missing. And definitely people lose trust in the data when this happens, and they obviously can't leverage it to make decisions if they can't use it. So that's definitely a pretty big problem. Another common problem that I know I definitely experience, and again, I think this is fairly common, is not being able to get data quickly enough to make decisions. And this is especially true if you're working for generally like a smaller company or a company that's pretty fast moving. It's very common in analytics, especially to maybe only load fresh data like once a day. And sometimes, and sometimes that can really hold up reporting. Other times just doing the analysis. So even if you're loading data more frequently, trying to wrangle all your data and transform it in a way that you can actually do the analysis takes a while. And if you can't do that quickly enough, the person has already moved on, right? They had to make the decision. If they didn't have the data, they're just going to go without it. And so this is definitely an issue. And it often has to do with the fact that when you're dealing with huge amounts of data, it can be very inefficient trying to load it into your data warehouse, trying to run efficient pipelines that get your data from the source to the destination can also be challenging, as well as like the transformations and just the general time it takes to get the data in a usable state. Here's another one that commonly pops up, which this is probably the most common thing that I would see happen, which was metrics and reporting would suddenly just change. One day they're one thing, or even a few hours later, something's different. And you're not always sure why. You're like, I don't know. Who made this change? Did someone go into this dashboard and change the SQL? Did somebody did something in the source data change? Like what changed? And you spend a lot of time trying to troubleshoot and trying to walk back and figure out exactly where in the whole process something changed to figure out and what's accurate. Was it accurate before? Is it accurate now? And that's something really difficult to deal with. And again, this really impacts people's ability to use data to make decisions, and definitely erodes trust in data. And then inconsistent values across reports. So this is probably one of my favorite, where the two people show up at the same meeting and they're like, wait a second, where did you get that number? My number said something different. And you're like, well, I got it from this source. And someone says, well, I got it from over here. Why aren't these the same? Causes a lot of confusion, causes a lot of time for the data team to go back and try to figure out what's going on. Why is it different? Again, data is very messy. It's very nuanced, and there's a ton of business logic that often needs to be applied to calculate even what seems like a very simple metric. And if you're not familiar with those nuances, it's very easy for two people to query the same thing and get a different answer. And so, again, that causes quite a bit of confusion. And so what do we get? Well, we get analysts, again, spending all of their time just cleaning and transforming and fixing data. And at my last company, we got to a point, I would say, where all of our analysts were spending upwards of 80 to, I would say, even 100% of their time, and at times while I was there, just doing this, not analysis, not delivering insights to stakeholders. And if we're not doing that, if we're not helping people make better decisions with data, then we're not doing our job, right? Because that's ultimately what we're trying to do. Data by itself is not valuable, right? Being able to leverage it for better decision making, that's where the value comes. And so again, what happens here is employees lose trust in the data, and so they don't feel like they can go do any self-service on their own. They don't feel like they can even trust a dashboard or read the data. Everybody needs a personal data analyst or data scientist just to handle basic data needs. And so then you get the long data breadline where everybody's waiting for the data team. And a lot of them can't wait, or they don't want to wait. And so they get out of line and they say, well, I just won't use data. And if that happens again and again, then you get stuck into a really big problem where your data team just isn't producing value. You are more of a cost to your team than you are an asset, okay? And at times in my career, this is where I felt like we were at, unfortunately. And so I was pretty determined to figure out how to make this better. I did not want to be in this situation. And these are really common problems. I hear this all the time. At first I was like, oh my gosh, what is wrong? I'm working at this like fast moving startup. We have a lot of great tools. We have really smart people. Like, I can't believe we're struggling with this. And the more and more I asked around, the more I saw that actually these were very common. So again, I wanted to find a solution for this. I didn't want to be stuck just cleaning and transforming data all day long. I wanted to have an impact. So, of course, the first thing I do is it's going to be easy. I just need more people. That's the problem, right? I don't have enough support. I can't do all this myself. And so I went out and hired a bunch of people. We also got a better BI tool. I put better in quotes there because I think if the underlying data isn't great and you're still cleaning it all, like a good tool can only do so much. And so I thought this was going to fix all of our problems. And they, I would say like there were small improvements, certainly with, more people that helps a little bit, but that's definitely not going to scale if you just have to keep hiring more and more people to do that. And the BI tool was easier to use, but we still saw a lot of the same problems, unfortunately. So this really didn't solve the problem. And so then I started thinking, okay, what are the real root causes here? Because at times we did make an impact, we were creating value. But most of the time we were struggling again to like repeat that. And so I noticed that a lot of the work we were doing, a lot of the processes we were doing was just very manual, felt very error prone and repetitive. And again, they didn't scale well with more data and more people. So I needed to find a way to make sure that we could create value in a very consistent and reliable and scalable way. So, what's interesting is that these problems of, repeat, error-prone processes and stuff, these aren't unique to data teams. This has happened in software engineering, and software engineering has been around for a long time, unlike, kind of the modern data science world. And they've solved a lot of these problems. And so we can borrow a lot of best practices from software engineering and apply them to the data world. And so some of these best practices that I'm talking about are version control, continuous integration, continuous development, automated testing, leveraging like very dry, don't repeat yourself if you're not familiar with that acronym, modular code, better documentation, and elasticity in the cloud. And what you get from that is this term analytics engineering. So hopefully some of you may have heard of this, some of you may have not, but again, this is kind of applying software engineering best practices to analytics. And I didn't come up with this term. I wish I had. I wish I was that smart. But Michael Kaminsky did in 2019. And he's a fairly prominent name in the data world. And he's one of the founders of Locally Optimistic. But he described analytics engineer as a role. And it's kind of this intersection of data engineering and data analysts and data scientists. And, they bring this software engineering best practices to the world of analytics. And I do agree that there is a role. In fact, I have 2 analytics engineers on my team right now. But I think it's actually more than a role. I think it's a whole discipline, analytics engineering. And I think that, everybody on a data team can really benefit if they are applying an analytics engineering mindset and discipline to their work. So around this time that I discovered analytics engineering, and I said, gosh, I think a lot of this would really help. I was approached by Aula, and they wanted to start a data team, and they were looking for someone to start it. And so this was a really unique opportunity because I could start from scratch. And so I had the opportunity of being able to try something new with a very small team and being able to iterate very quickly and see the benefits and see what works and what doesn't work. When you're at a very large data team at a large company, that's harder to do, to understand, like, is this really the answer? And so this sounded I joined Ella for many reasons, but this one in particular was definitely caught my eye and I was very excited about. So now I'm going to walk through what I actually did differently, and some of the results of that. So the first thing that I did was address some of those problems that I had seen with data pipelines and pulling, specifically the ETL process of pulling data from the source and loading it into the destination. I mentioned before that at my last company, we had all these pipelines that constantly broke or couldn't handle schema changes, or just would silently fail or something. And we had, I think, 3 data engineers that were spending all of their time basically just maintaining. I mean, they hardly had time to even build and add new data sources because they were just maintaining these scripts. And so the very first thing I did was ditch custom scripts. When there is a very common problem out in the world, somebody smart sees that problem and they come up with a solution. And so somebody saw this space and said, I'm going to build a product that does this. Okay. And so what I did at Ella is I leveraged Fivetran and Stitch, which are ETL tools out there. And so that I could, and they basically work with a lot of your most popular source data, and then load it into your very common like destinations. So your Redshift, your Snowflake, your Azure, your BigQuery, those kind of things. This allowed me to basically, I set up, I think, 40 data sources in less than 2 weeks, all by myself. And I'm not saying that to brag. I'm saying it to say how easy this was. I'm not that good, but previously at my old company had taken 3 data engineers to manage like full time. I was able to set up more sources of data in a very quick amount of time, and everything is fully managed. So when there are source schema changes, Fivetran and Stitch recognize those, they normalize that data, they handle those schema changes, and then they load that into my destination, which is Snowflake. I also moved from an ETL framework to an ELT. So for those of you who are not familiar with this acronym, it stands for extract, transform, and load. And so the idea is that, nowadays, storage of data is very, very cheap. And so you don't have to worry so much about like, oh, do I need this data? Do I not need this data? And only loading in the data you need. You can basically just dump everything in there and then figure out later what you need. And there's a lot more compute power in data warehouses nowadays as well to help you do those transformations. And so the big reason that I did this, was switching to this one, was the fact that when transformations were happening before they got loaded into the data warehouse, I really had no insight into them. It was very difficult to see what was going on in those transformation scripts. So if something did change in the data, I didn't have the raw data to go back to say like, here was the raw data, here's the new data, like what's different and what changed. And that can be definitely very frustrating for an analyst when you're trying to troubleshoot a problem, or maybe re-aggregate something in a different way. And so it's really helpful to have that raw data in there. It also really sped up the number of time, basically being able to load data. It made it much more efficient to just kind of dump it in there, and we could get data a lot faster. And I already mentioned it was much more reliable. The next thing that I did was not loading data right into production. So your database that all your end users are querying, the database that your BI tool is pointing to, that was basically like a production database. So if you think in software engineering, you have like a testing environment or a staging environment, and then you have your production environment. You don't just go make a change right in production, right, that everybody could see, because you haven't tested it yet. You don't know if it's working, whatever. And so the same concept can be applied to analytics. And so in Snowflake, you can, create tons of different databases and schemas. And so I created basically a separate database for every one of my transformation tools. And so I can load them in there, and then it's not messing with any of the data that my end users are querying. So one, you can't have people accessing raw data, which can lead to that confusion when people are querying different things and they have different numbers or something. And on top of that, it also helps with being able to avoid colliding. So what I mean by that is often when you have someone querying the same database that you're trying to load data in, or even the same table, you can get kind of a collision where they're competing for resources. And that's definitely a problem, and it can slow things down, and or just put things in the queue and cause like this whole backlog of either data trying to get loaded or people querying, and it just it causes a huge problem. And so this is something I experienced quite a bit, especially on Amazon Redshift, which it is a modern data cloud warehouse, but that problem happened quite often on there. So by kind of adopting this new framework where I was loading data into a separate database, it really helped with some of those problems. I also moved from, again, Redshift to Snowflake to take better advantage of elasticity in the cloud. So a lot of data warehouses are doing this now, or trying to move towards this, because the benefits are so huge, but they separate storage from compute. So what this means is you pay for storage separately, and then you can pay for compute separately. So if you have, let's say, tons and tons of data, but maybe you don't have tons of usage or tons of querying, you still have to, you will have to like scale up and add more nodes to your cloud data warehouse because you have so much storage, right? It's all like bundled together, and they're all using the same resources as well. So that becomes a problem, because when you're all fighting for the same resources, you can get really bogged down. And so what's really nice about Snowflake is they separate that out. And so I pay for storage, right? I pay for what I'm storing, and storage is so cheap. It's trivial, honestly, nowadays. And then I pay for compute, and I can also I can separate and create all these different, they call them warehouses in Snowflake, but you can think of a warehouse as like a server. And so I can have a dedicated warehouse for every single operation that I'm doing. So on the left-hand side here, you see, you could have a warehouse for your SQL analyst. You could have one for ETL and processing, and in each one of these different functions. And that's exactly what I did. And so you can see here on the right, a list of my warehouses. And these are all the ones I have right now, but I could get even more granular than this if I really wanted to. And so I have specific warehouses for each of my ETL pipelines. I use a different warehouse for people querying the database. I use a different warehouse for people in the BI tool. And so I can have all these different warehouses, and they can all be different sizes. So if I need a lot more power on my, lot more compute power loading data, I can scale up that specific warehouse. And you only pay for what you use. And so I don't have all these nodes and all these servers just running all the time, which is really expensive, really inefficient, and they're all fighting for the same resources. I can, scale each one of these separately. And it's, like I said, it's very efficient, and they're not competing for resources, and I have a lot less problems doing this. And so this is something that made quite a big difference, not only in cost, but just separating things out and making everything run much more efficiently. So faster loading, faster querying. So for my transformations, I leverage DBT. And if you haven't heard of the data build tool, I highly recommend that you go look it up after this talk, because it is an absolute game changer. I did start using it at my last company. I think I've been using it since about 2017. And it makes transformations unbelievably easy. So I'm going to walk through some of the high level pieces of DBT, but there's tons of features of it, so I won't go through everything here. But essentially, DBT allows you to put all of your transformations in SQL scripts and YAML files, okay? And so here on the left, you can see just a quick screenshot of our DBT project at Aula. This is just one directory, and you see just a list of separate SQL files. And so each one of these files has a specific transformation in it. And then there's a YAML file associated with it that you can set configurations for. Do you want this to produce a table? Do you want this to produce a view? You can put documentation in there. You can put testing. You can put all sorts of stuff in your YAML file. And so this allows really any analyst, any data scientist, a data engineer, anybody can go and write these transformation scripts. It's very common to know SQL in the data world. And so when you have a tool that is using the language that many, many people speak, it makes it much more accessible. On the right-hand side, you'll see that every project comes with a project YAML file. And so these are the project level configurations. And so this is just kind of like a dummy version here. This is not my version. So you would actually fill in every one of those places that says like directory path or profile name, you'd fill in actual values. But again, this is a place where you can configure everything for your project. And so it automatically handles a lot of the processing and where things are getting created and how they're getting created, and makes it quite easy. And so with this allowed us to, again, use that ELT framework as opposed to ETL, and makes the transformations a lot more visible. We have a lot more insight into what's going on, and analysts and data scientists aren't running the same codes and doing this, cleaning the data the same way over and over and over again, because they're all stored in these files here. DBT also allows you to do what's called a directed acyclic graph. And so this can show you the dependencies. So you'll notice here on the left-hand side, here is one of my models, which is called it's called comments. Okay, so these are comments in our software. So when a student makes like a comment on a post or in the feed or something like that, it gets stored in here. And so we can see that I'm configuring this as a table. It's a simple SQL select statement. And then you notice that ref down there. And so that reference basically tells it like, hey, pull from this other model. And so DBT handles all these dependencies for you. So it knows which of these, you have all these files in your project, but it knows which one needs to be run first, which one needs to be run next. And with those refs, you can also just run pieces of your project. So I literally we have hundreds and hundreds of models, maybe even over 1,000. I'd have to check. But and if I just want to say, hey, I need to update this one source data, and I just want to run all the downstream, all the children of that one model, you can do that very easily. And so that makes it really easy. And it comes with this nice visualization piece as well. So you can see where data is coming from and where it's going. And so again, this really helps more easily transform data and clean it up. So you're not repeating yourself over and over again, and tracking down problems in data and understanding where it's coming from. Testing. Okay, so automated testing is so common in the software engineering world, and it's really just starting to break into the data world now. And DBT allows you to write these very simple tests. Out of the box, it comes with something called the schema test, which are things like a value could never be null, or a value has to be unique if it's like a primary key, or like on the left-hand side, you can see there's accepted values for a respondent type, which is educator, student, or other, or whatever. So there's all these very easy tests that you can write. And then you can also write custom tests of any type of, really any SQL script that you can come up with. You can write a test for that. And so all of our models have tests, and I'm sure we could write a lot more tests too, but every time we run our transformation, all these tests run, and they check our data. And so we have tests running to check source data. We have tests running to confirm business logic that might be in there. We can have tests to check for certain metrics, like if this value should never be lower than this other value, we can run a test for that. If if you have a start date and an end date, and you're like, well, the end date should never be before the start date, you can write a test for that. And so by doing this, not only does this just improve quality and ensure a lot less problems go out in your reporting and everything, but it makes development of transformation so much faster, because I don't have to sit there and think like, what are all the things I need to check for downstream when I make this change, and I don't have to manually test everything. I can just, these tests are just going to run automatically and check a lot of that stuff for me. There's also packages that you can load into DBT. I'm not going to get into that today for the sake of time, but there's a lot of packages in there that have additional testing things and ways to quickly validate changes in models as well, which is really nice. And then at the bottom here, you can see a screenshot. So like our transformation project has over 2,500 tests. And you can see an example there of tests not failing, but just giving us a warning. So you can set like warnings as well. So this has really helped improve the overall quality of data and ensure we're not pushing bugs and nasty stuff's getting into our production database. And then automating transformations. So sometimes people have transformations and they'll run them manually, or, they can't, they're difficult to do. And so being able to automate it is definitely a big win. My last company, we did, we had all our transformation jobs that were automated. They were wrapped into our loading jobs, but they were doing it with just like a standard cron job, which if you have used cron, you know what I'm talking about. If you haven't used cron, just stay away. It's not the easiest, most user-friendly way to schedule things. But I use DBG Cloud, which there's actually a free version, and even the paid version is very inexpensive to kind of be able to schedule all these transformation jobs, and you can set dependencies as well. And so that has really helped keep everything up to date. So, we come into work and things are just ready to go, right? All the data is already transformed. It's fresh. It's right there, which is super nice. And other options for this, sometimes people use like Airflow, Luigi, or there's Meltano. There's several other great tools out there for that are kind of orchestrators and schedulers built in. Alerting. Yeah, so this is something that is, for whatever reason, it's just not as common in the data world to have a lot of alerting set up. I think most data teams have some alerting for things like failing, but not everything. And so I have set up alerting just about everywhere because I don't want things to silently fail. That's the worst. When a stakeholder comes to you and tells you something's wrong with your data, like it just makes you cringe. Like if something does go wrong, I want to know about it first. And I want to be able to a chance to fix it before anybody even notices. So here on the left is just a warning coming from Fivetran from my loads. And on the right here, I have alerts going into a Slack channel that we use for all of our data notifications. And so again, this really helps understand what's going on in our data, and lets us, very easily be able to go, hey, there's a problem and the problem's right here, and we can go quickly fix it. And we don't have to spend all day trying to troubleshoot and figure out what's going on. So here is just kind of a quick shot of high level of our data stack at Aula. So you can see some of our sources here. And again, we have our data loaders putting data into those raw databases in Snowflake. And then we're using DBT to transform it and load it into this analytics kind of production database. And then we use Python notebooks or Jupyter notebooks. And then we, right now we're just using Metabase, which is an open source BI tool. Well, they have a paid version as well. And yeah, and so that's our basic data stack right now. So other things that I have done are implement version control. This is pretty huge. I definitely had things before, even like dashboards and things that, It's like you're making changes, you make a change, and like that's it. Everybody can see the change. Again, it's like right there and for everybody to see. And you're like, what was the previous version? I don't remember. Why did this number change? And you can't go back and see the previous version if there's no version control. And so version control really, really helps with that. And so all of our transformations, especially, are made on branches with Git, and we use GitHub to manage that. And then we also have branch schemas in Snowflake for each developer. So when you are developing and maybe create a new model for something, some type of data model, or maybe you change a data model, whatever it might be, when you run it in the configurations for the project, it knows that based on your profile to take it, it'll read the production data and create a branch schema. Okay, so it's not creating it right in production. So it's basically creating a testing environment for you. And so you can see all of your changes and what the data will look like. And then you still have the production data that you can compare it to. So it makes testing a lot easier as well. And having those testing environments are just huge. It makes a huge difference. It really prevents a lot of problems going in that you maybe wouldn't have been able to see. And again, when things do happen that you didn't expect, you can easily roll back, or you can see the two different versions. And yeah, it's phenomenal. And so with that, we also do pull request reviews and we also have continuous integration, continuous development. So excuse me one second. Okay, so
hey, sorry to interrupt, Kelly. We had a timely question from Renee,
yes,
who I think came a little bit late to the presentation, but was just wondering what type of data is it that you're version controlling? Transactional, analytical, warehouse data, like what kind of data exactly?
Yeah, so we have all sorts of data. We have usage data from our software. So any of our event logs that come through, and we build models off of those that can all those changes and transformations can go through version control. We also have like backend database logs from MongoDB. We ingest qualitative data as well, our survey data. So that can come through as on top of that. We do have other transactional data coming from some of our operational tools that we use across Aula. And so hopefully that answers your question. But yeah, so it's kind of a mix of all different things that can get version controlled. So here's an example of a pull request here, and you can see that when a pull request, we have it connected to DBG Cloud, and you can integrate it with other tools as well, like Airflow, for example. And so when this pull request gets opened, it automatically pings DBG Cloud and says, okay, I'm going to run this branch, and it creates a branch schema. And if it successfully runs and successfully passes all the tests or whatever you have set up in your job, then it'll, give it the green check mark. And so we have it set up that like it can't get merged to master until it has passed these checked. And then you can see it also requires at least one person to review and approve the pull request. So again, this really helps with quality, ensuring everything is running, because we all know that sometimes you run something in a small batch or in a test environment and it doesn't quite operate the same when you're running it locally as when you're running it on a server or something like that. And so this really helps with that as well. And it's just automated, so I don't have to like, oh, did I run it? I can't remember if I ran it or checked it since I made this last change or whatever. And so that's all automated, which is really nice. And you can see here in DBG Cloud, this is what that exact run looks like. And so I can go here and see exactly what happened as well. And and here's a screenshot of Snowflake, the analytics database. That's our production database. And you can see these separate schemas in here. And so there was that PR 231, and here was the branch schema that it automatically created, and created all the schemas associated with it and all the tables and views and everything in there. And so this is, excuse me, skipping ahead here. So this is great. And this also allows us, if something does get pushed that shouldn't, with CI/CD, you can just roll back. So if I'm not confident that I can find the problem and fix it very quickly, I can just roll back to the previous version and rerun it, and then I can go hunt down the problem. Luckily I've only had to do that once in like the 2 years that I've been doing this, so that's a good sign, I think. So the next thing that we did at Aula was make sure that we're including a lot of our business logic in our transformations. Okay, I mentioned before, data is very messy. It's very nuanced. It's very difficult to understand exactly how something is calculated. And it's so easy for two people to query the same thing and get a slightly different answer. And so you can see here, this is a script for a model I created called, I think it's called daily space engagement. It doesn't really matter what it's called, but you can see kind of here on line 17, we have, okay, these event logs, they have to be of these event types, all right? And for them to count as engagement. So engagement or activity, active user or engaged user, those are very loaded terms in the tech world. They get used all the time and they mean something different at every single company. And so it's really difficult. You can see like what that SQL looks like, where the event has to equal one of those things, and that would be hard to remember, especially for somebody that's maybe not really familiar with this data. There's not a subject matter expertise, and so by building that business logic into the transformation and just having that already calculated for your end user to query, even if from point and click or whatever, then it takes a lot of the mystery out and creates a lot more consistency in your reporting. I also definitely recommend pre-aggregating a lot of common metrics for similar reasons. And we've done this at Aula as well. So on the left-hand side, you'll see, again, we're pulling from our events table and we're calculating, or pre-aggregating, everything at kind of a daily level. And so this is a very common thing for people to do is I want to know how many times this user did this every single day, or I want to know how many times this happened over the last month. And and we have, it's over 1 billion rows just in this one table. And, if you want instant, results to come back, pre-aggregating takes a lot of the heavy lifting out of it, because now I might have, let's say 10 people that go in that day and query that same table with that roughly the same aggregation. I only have to transform it once. So I transform it one time, load it in there as a table. And again, data storage is cheap. Okay. So I don't care that I'm loading, kind of aggregating this data and storing it essentially twice, but in also an aggregated format, because the storage is cheap. But now I'm saving a ton on compute and I'm getting faster results for my end users by pre-aggregating that. And so on the left-hand side, I'm doing that in my scripts. I can also do that in my BI tool, and most BI tools allow for this as well, where I can kind of save these metrics in there and they're just ready and available for people to use, and they can also see what's going on. So also documenting data models. I think it's no secret that documentation is generally like a good thing that we should all do, and it certainly helps us. If I document a project and I need to go back and reference it, or if I document my code, I can go in 6 months. It's unbelievable how you can write code and feel so familiar with it. And then you go back and you're like, what the heck was I doing here? But also documenting your data models, not just for your own data team, which is obviously a huge benefit if everybody knows what's going on, but also documenting for end users. If everybody knows what a table means, what grain the table's at, what the columns mean, it can really help usage and people, feeling like they can trust the data because they know what's going on. They know how things are being calculated. Oops, too far. And then documentation is good, but you have to make it visible to your end users. And I've tried this so many different ways, creating like data dictionaries and things. And it seems like no matter how good of a data dictionary you create, if it is in a separate tab or you have to go to a different place, like people just don't want to do that. So making it visible in your BI tool is a pretty big step, because then as people are querying that data, and I have an example here of like writing a SQL query, but this works for point and click as well. If they can see that documentation right next to the data they're using, it's a game changer, because it just takes a lot of friction out of that process of trying to understand that data. And this documentation is actually reading directly from our DBT model and those YAML files that I talked about earlier. So something I've also struggled with is you might have a data dictionary built into your BI tool, and then you're documenting somewhere else. And how do you make those consistent? And when one changes, how do you keep them in line? And so that's really tough. And so there are luckily a lot of really smart people that are thinking about this, and thinking about data catalogs and data governance and whatnot, and trying to find easier ways to do this. And so there are a lot of options out there, and there are a lot of options in DBT as well, which is what I'm using here. This is something that this is kind of a TBD for me. I've seen and talked to people that use this concept of verified dashboards, and basically these are content, and I say dashboards here. This could be really any data product, but things that the data team has like signed off on and says, we guarantee this is good. This has been through all the proper checks and everything, and we are here to maintain it and make sure this is always top-notch quality. And from what I've heard, this is a common problem where people go into Tableau or they go into Looker or wherever, and they're like, I don't even know where to start. Like, I see all these dashboards, or I search for this particular thing, like how many users did this, and I get 50 results back, and I don't know which one to look at. And that's really tough. And so being able to use to kind of create a check marker, signal to your end users that this is the dashboard that we maintain, is really good. And so this is something we're just looking into. So I don't have any firsthand experience creating the verified thing. It's something I've done in the past with some success, but I'm looking forward to doing it more. And then also using, again, I say dashboard review process, but it really could be any data product. I haven't found a great way to do this. So if anybody has any suggestions, let me know. But right now I'm just using Miro. So if you haven't used Miro, it's a really great collaboration tool. And we will just screenshot our dashboards or whatever data product we have, and we put it in a Miro, and you can see all these little yellow comment things on there. And so we can drop comments directly on the place that we want to, say what's going on here. And so this is kind of this is a dummy one here, but you can see that we can all comment and collaborate with each other and say, hey, I think, this graph should look like this, or can you switch the wording on this thing? Or, hey, this, display the numbers like this. And so it's a sort of a PR review process, a bit hacky one, but it seems to be working really well for us, and it doesn't take too much time at all. And so it's another way to just ensure that we're putting out good quality things. And it's kind of our first step to getting to that verified dashboard status. So what are the results? Okay, so I talked here through the left of things I've experienced personally and I've seen are so common, like missing or incorrect data. And now we have very accurate, reliable reporting, slow data refreshes. Now I have very robust, ELT process. Again, I rarely ever see failures from our data loads. And even when I occasionally do, it's something that's usually very easy to fix and very easy to find, which I think is very important. So metrics suddenly changing, inconsistent values across metrics, being able to have this consistent reporting, this data lineage, so you know what's happening where and what transformations are being applied is so key. And we now have our analysts are focused on analysis and delivering value to our decision makers. Our analysts are not spending time, they're creating reporting, they're creating analysis, but they're really not spending time cleaning and transforming data. And we do have analytics engineers, which spend time doing that, but in a once they build one model, they go and build the next model, and they're not finding themselves, they're always doing new things. They're not finding themselves like, it feels like it's maintaining the same things over and over again, which is really frustrating. And, here at Aula, we are really seeing data-informed decision-making happening. And I still think overall, like, we're still early in our journey. There's a lot more we want to do, but it's really nice seeing, like, our product team, for example, we do demos at the end of every sprint, and watching them go into demo and say, hey, this is our success criteria for this new feature we just launched, and here's the metric, and here's what we're seeing. And the data team's like, I didn't pull that metric for them. They did that themselves, and they felt confident in there and going and doing that. And that's really, really awesome to see. So it's been great. It's been quite a journey, and I'm very proud of my team and where we're at. Now, I showed, oops, jumped ahead a little bit. So I showed this slide at the beginning where I said, I thought I had all the pieces in place. And, I found out really through all of this that it looks something more like this, with all these other things in place. It's not just a couple of tools and a data engineer and a data analyst to be successful. I found that these are really some of the additional key things you need to have in place to create value for your team and avoid that 80-20 trap. So some of you might be wondering, well, that sounds really great, but she had this very small team at a small software startup, and she said she could iterate quickly. I don't know if that's going to work for me. And I think it can. There's nothing that I did here that is prohibitive really to any industry or any company size or anything like that. It is hard if you have a team, a very large team with a lot of legacy processes and a legacy tools that you would have to kind of change, or just in a company that's generally adverse to change, that is hard. And so what I have found is kind of that this picture on the right is advertising like that, or demonstrating the MVP model, where you build like the very tiniest thing that you can do that just kind of that still works. And that's the approach that I think works best in these scenarios. Is you start with something really small. Maybe your goal is to fix just one tiny problem, or one data set, or one report, or maybe you just work with just the marketing team or something like that. And you find something that you can just prove out the value very quickly, and you get an advocate, and you start getting momentum, and then you can just keep building that momentum and keep changing. And once people really start to see those results, it becomes easier and easier, kind of like a flywheel. So that's kind of my best piece of advice there. If you're in this boat and you're like, I don't know if this would work. So in conclusion, we have tons of data. A lot of us are trying to democratize data, make it more accessible, spend our time helping people create value with data. And with all those new things and new opportunities comes a lot of challenges. And it is really difficult. Again, these are very common problems of people trying to create consistent value for their companies through data. And so by leveraging analytics engineering and modern data tooling, I was able to do this at Aula, and I think it's very, very crucial to success. So thank you all. I appreciate you listening for a long time, and I'm happy to answer any questions now.
Yeah, I think we have like a couple of questions on deck in the chat here. So going in chronological order, like Renee, do you want to ask a couple of the questions that you had? Hey, are you able to unmute yourself, or do I need to do that?
I have a question. This is Renee.
Hey, Renee.
Hey, Renee.
Hello. It's one I typed in the chat earlier, but I was trying to give other people time. It was just silent. It's in the engineering world, when I was in software engineering as a project manager, it was release management, and we actually had a source code control system where the code was logged in, it would have to be checked out. And we did the same versioning of product document. Engineering had to follow it, documentation had to follow it, etc. And then for code consistency, the engineering team, constantly use APIs to guide the work. And so translating that forward in the data world, we just write thousands of lines and nobody checks it.
Yeah.
I don't get it. I'm a little confused because I'm not formally project managing. I'm knee deep in data, but okay, there's my question. I don't want to over explain, but I use some buzzwords from back in R&D, research and development, to find out how it works with data, because I love what I do, but it's just too mom and pop. It's too ad.
Yeah, I've seen this a lot. Companies that have been around a while have these scripts stored in SQL Server or some old IBM database or something, and it's just like this monster 5,000 line script or something. And so it works for the most part, but people struggle, and they're afraid to even go in there and mess with it, which is really hard. And so something that I like about DBT is, it doesn't have that mentality. That's hard, right? It's hard to find things, and when you have such a long script. And so, being able to create like packages and functions and separate it all out into very specific pieces of logic in your transformation is really crucial to success. And so that can be very difficult. And I actually had to do this at a prior company I was at, where someone gave me this massive query, and they said, we're switching databases. You need to go rewrite this for this new database and make it work. And so I looked at it and I'm like, oh no, like this is not going to be good. And so being able to break it up and pull it apart and everything is really key to how to make that work. But it's not an easy task.
And so I'm dealing with stored procedures now. And for this particularly, remember you said the one thing. So I picked a one thing project with a third-party vendor application. I went and found a project sponsor. I recruited my own sponsor in operations to drive it, because operations should drive, not tech, right, or analytics, but it needs to be done for data cleanup. Yep. So how do you handle or address analysts doing things similarly? How you compute aggregation, how you establish uniqueness. And by the way, I'm not no SQL, like I'm in a traditional SQL Server, Tableau, it's not that normalized, and it certainly isn't in the data warehouse, but I'm in a traditional relational database environment, not graph or anything like that. Mm-hmm. So in that respect, do you have rules for, well, this is how we compute aggregations on these type things, or this is how we attach a person to a customer, let me not use shop talk, customers to their transactions. These are the 5 things we tend to look at in general between a customer and the customer's transaction or something. I'm making this up, trying to just be generic. But do you have those rules in place for these 20 queries that we tend to write most often? And when you do your work, these are the checks that you do. Or if we're building from these 2 tables, and most things in my world are a left join, but do you have code stored. And the only analogy from software engineering, all I thought of was API. But right now we generate it from scratch. And when I asked about code review, they said, well, people come up with things different ways, and it's just up to you to get the right answer. And I'm just going, what?
Oh,
No,
no.
yeah, that's tough. Yeah, so we do, and there's a couple different there's a lot of things around modeling best practices, and there's things around like Kimball's method, or star schemas, and or creating like really wide tables where everything is like pre-joined, and how to do that. And so I do definitely recommend, I didn't talk about it today, but having kind of a modeling best practices, and it can vary by company of how you do things. And so, we like to pre-aggregate certain things, and we like to make, wider tables, and there's other things, other ways of modeling that we're actually exploring to make it easier. But having kind of that best practice and say like, hey, this is how we break up transformations, and we do it in this way. And this is when we decide to pre-join things, and this is when we decide not to pre-join it. And this is when we clean up column names, and we always name them something like this, and so it's there for everybody. And having that, it's almost like a coding style guide, except for like modeling or transformations. And it makes a big difference. It takes a load off of your analysts and your data scientists and data engineers, who then don't have to think about it so much, and they can just do it. And there's even with some of that stuff, there's like linters and stuff available to make it easier as well when it comes to more like the style stuff. But for sure, for the modeling best practices, just creating some type of guide is definitely helpful.
And organizationally, all of the functions you just named are in an engineering reporting structure, an analytics reporting structure, or might it be operation?
Sorry, are you asking where that would be?
Yeah. Yes, ma'am.
Yes. So in my opinion, it should be kind of the data team owning that. But if you are producing data for the marketing team or an operational team, obviously you want a stakeholder from that team, and you want to really partner with them and understand how they're using that data. And I think that's really that's pretty necessary for success. Is you want to understand how people are querying it. Oh, I see that they need to disjoint all the time, or I see that they calculate this metric, daily or weekly or whatever. And so understanding that is pretty important.
Okay. I've got like 8 more questions, but this has been enough group's time. So thank you.
I see some questions in here about why I'm using Fivetran and Stitch. I get this all the time, and I should have just addressed it. I should know to answer that question now. So Fivetran and Stitch are very, very similar tools. There are some differences. Stitch tends to be, I'd say, a little bit cheaper, especially with smaller amounts of data. But I don't think they have as like robust of support and some other things that maybe are lacking just a little bit. They're both wonderful tools, and I love them and would recommend them to both. The reason I am using both is not because I like more variety in my life. It is because they have different integrations available. So there was a particular data source that wasn't available in one of the tools, and the other one had a different one or something. So I ended up using both. So that's why I'm using both.
Awesome. Will, looks like you also had a question. Did you get that answered, or would you like to chat now?
I'd love to ask that again. Kelly, this has been great. For getting all of those metrics and the documentation, that metadata, into Metabase from DBT, what does that process look like?
It's actually pretty easy. So when you use DBT on your project file, which I don't know if I have a screenshot here, but it would be here. So yeah, you can't, I don't have an example, but under that, the configuration there where it says like models and model config, there's a configuration there that's called persist docs. And when you set that to true, then it will store all those, like your descriptions for your column names and everything. It will store it in Snowflake as comments. And then Metabase just reads that in and pushes it right into your into that data dictionary built into Metabase. And I think this works for other data warehouses and other BI tools as well. There are also packages with DBT that help that integration between the BI tools and DBT in your data warehouse, I should say. And there's other functionality too, like understanding downstream dependencies. So I showed like the dependency graph, which is great. So I can see where data is going, but the end of this graph is a model. And so I don't know like which queries are using this. So if I decide, in fact, this happened today when at work was, we were actually changing the name of a column and we said, okay, which queries are querying this and which queries are basically out there that are going to break now. And so we had to go query the back end of our BI tool to figure that out. But there's something in DBT called exposures, which actually connects your DAG here to those downstream dependencies in your BI tools. And again, like you can, that comes through packages. And so you can integrate all that in there. So yeah, it's super helpful. Hopefully I answered your question.
Yeah, that is excellent. Thank you.
Yeah, this is great info. Banjo, I think you had a question about the learning curve for DBT adoption.
Yeah, I see that question there. And I would say it's actually, well, it depends. If you're used to writing SQL and you're familiar with data, it's pretty easy because you're essentially just writing a SQL script. And these configurations, I have an example right here that I'm showing on the slide. You're just saying it's a table, and there are certain, there's definitely some nuances and some best practices and ways to do it. But overall, I'd say the learning curve is not very steep. I had somebody that I hired a few months ago, and she came from a manufacturing company, and they were using pretty old legacy databases and systems. And although she was doing things she had a lot of friction with how she was doing things. And as part of the hiring process, I had a project that I gave candidates where I gave them the start of a DBT project. And I gave them access to a database and kind of had some problems to walk through and some models to create. But I included some instructions, and I also included links to the different documentation because I wanted to make sure that it was inclusive and I wasn't ruling candidates out that might be really smart and really talented, but had just never used DBT before. And she had never used DBT before, had never even, I don't even know if she'd heard of it. And well, maybe she had, but she'd never used it, never touched it. And she was able to turn something around to me the very next day, submit like part of the project using DBT. And so, I guess like that's a testament to the fact that I don't think it's a super high learning curve. There's a lot of advanced features. There's things in there called Jinja, which is basic. It's like Python templating that allows you to do things like loops in SQL that you normally wouldn't be able to do in SQL. So there's some advanced features for sure. But as far as like just getting started and getting things going, I'd say not steep at all.
Awesome. SS, did that address your question, or do you have a more detail that you were hoping to go into? Okay, awesome. We have a couple more minutes, Renee, if you wanted to, I know you had a lot of questions. If you wanted to go down that list a little bit more, you know, we have a little bit extra time. You can feel free to.
Okay, I just unmuted. I typed one in the chat, and with so many tools, many you haven't named, I just put in the chat a basic question, right? Always keep it simple and then get complicated if if you have to. So basic tool list, SQL. Does it have to be into for me in a Microsoft environment, I would refer to it as transact SQL. So I'm not conversational in stored procedure script writing. I can read them, interpret them, modify them, but writing them from scratch, I can't do that like code. But what would you call the tool list? Python? Yeah, what's the tool list that you would name?
I mean, it depends on what the goal is, what your objective is, and what you're trying to accomplish, and certainly your role.
Analytics engineering.
Okay, so for analytics engineering, SQL is an absolute must in terms of like coding languages. I think Python is probably the next highest on the list, but if you're very strong in SQL, that and maybe just have like a basic understanding of Python,
Okay.
you can that gets you pretty far right there. Certainly, if you are familiar with modeling best practices and ways of modeling, I think that is also very important. And understanding different, nuances between data warehouses and things. So, for example, a relational database versus like a NoSQL database like MongoDB, and understanding a columnar store versus a row-based store. And I think those are important to know as well. If you're familiar with some of these tools here, I think that's definitely helpful. So, but I know when I hire people, I'm fairly tool agnostic. If if they've used BigQuery or Redshift or whatever, even though I'm using Snowflake, like I think you can pick up Snowflake, like, right? I'm not too concerned about that. If you've used Prefect or Dagster and not Airflow, I think it's kind of a similar thing. So, just being able to know, like, I've used a loader tool, I've used an orchestrator, like just having some experience in some of those tools and really understanding that, I think is pretty important.
It's just to me, because I asked this in a prior question, but I'm biased at this point. I absolutely believe at this point that a data analytics BI trained person has no business reporting through operations, because operations will treat us like a report writer.
Well, I think it depends on your company and your organization. There's different models for data teams. So, there's obviously the kind of the center of excellence or centralized data team organizational structure where everybody's kind of in the same. And then there are the embedded analyst approach. So where you just have an analyst in operations, an analyst in marketing, an analyst here. And there's a combination where it's like a hub and spoke model, where you might have a small centralized team kind of creating the foundation for data for everybody to use. And then there's specific analysts embedded in each of those departments that really have that subject matter expertise. And I think that works out really generally very, very well. So I don't think that it can't work if you have somebody in there. If somebody is turning into a reporting monkey, that tells me that there's probably some inefficiencies in the way that reporting is being generated. If the fact that they're spending all their time doing reporting, if there's this idea out there of like self-service data analytics, or sometimes people even say like citizen data analyst. I'm not sure I'm totally bought into that. Like, I don't think everybody is just going to be a data analyst, because like, I don't know. I just don't think there's a lot of truth to that. But I think there is a level of self-service where if I'm a marketing person, I can go and query my own marketing data every day for like day-to-day operational things, or I can go to my dashboard and I can understand, why do I see a drop in lead generation? And I can filter down and I can ask questions and kind of hypothesize and be like, well, I wonder, I should check this. And, and you go check that. So I think like those type of things like can be self-service. And so if you set up your reporting in a way that makes that really easy, then that analyst can spend more time doing actual analysis and delivering insights as opposed to being, just all day focused on reporting.
Thank you so much, Kelly. I really hate to cut off all of the questions because I think a lot of us are really excited about everything that you talked about and have a ton of questions, and we could be here all night. I only reserved our Zoom account for 90 minutes, so I do have to shut everything down at this point. If you all want to follow up on this and chat more about it, I welcome you all to join us on the Women Who Code DC Slack, and I just put that link in the chat. You can also find it on Meetup at the event description. And this will also be posted to YouTube so that if you forgot something or didn't take notes, you can always go back and watch it again. Thank you so much, Kelly. This was really great and really exciting. And I'm gonna go Google DBT right away. This is great.
Yes, thank you for having me. I really appreciate it.
And Kelly also put her LinkedIn in the chat just so everybody sees that if you all want to connect with her and follow up later. So